Hey guys, welcome to another episode of Learn with Sir Glenn. So for today's topic, we will going to discuss Arithmetic Series. So let's go! So before we proceed with our topic, let's try to add the following mentally. Can you do it? Let's try. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. The answer is 55. Let's try another one. So 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20. The answer is 110. How about 1 plus 2 plus 3 plus 4 plus 5 and so on plus 97 plus 98 plus 99 plus 100. Can you still do it? Okay. Did you know that there is an easy way of adding this set of numbers? So instead of adding it from left to right, we can actually add the numbers this way. So 1 plus 10 is 11, 2 plus 9 is also 11, 3 plus 8 is also 11, 4 plus 7 is 11, and 5 plus 6 is also 11. Then we just simply add these 5 11s, which will give us 55, which is our answer a while ago. So if you observe what we did on this example, you will notice that we were able to get 5 pairs of 11 from the 10 terms of sequence. And aside from that, we can also simplify the process by multiplying 5 times 11, where 5 is the 5 pairs that we were able to produce from 10 terms of sequence, and 11 is the sum of the first and the last term. Let's try to apply it on the other example. Let's try 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20. So instead of adding it from left to right, we're just going to add the first and the last term, which will give us 22. So 22 is the sum of the first and the last term. And then we're going to get how many pairs can we have on this sequence. So there are actually 5 pairs that we can make. So instead of adding it from left to right, we're just going to multiply 5 times 22, which will give us 110, which is also our answer on this example a while ago. Okay, so let's try it now with 1 plus 2 plus 3 plus 4 plus 5 up to 100. So instead of adding the numbers from left to right, we can just simply add 1 and 100, which will give us 101. So this is our sum for the first and the last term. Now we have to determine how many pairs of numbers can we have from 1 to 100. So there are actually 50 pairs of numbers. So you can obtain this by taking the half of the number of terms. So since there are 100s, taking half of 100 numbers will give you 50. So all we have to do now is to multiply 50 times 101, which will give us 5,050. What we actually did here is an example of arithmetic series. So by definition, the arithmetic series is the sum of terms of a finite arithmetic sequence, just like the 1 plus 2 plus 3 plus 4 up to 10, 2 plus 4 plus 6 plus 8 up to 20, and this one, 1 plus 2 plus 3 plus 4 plus 5 up to 100. So the arithmetic series is denoted by S sub n. And by using the concept that we used a while ago, we can actually derive the formula for the arithmetic series. So since it is denoted by S sub n, we will have S sub n. S sub n is equal to, and notice that on our previous example, we have to get the half of the terms. And in general form, that will give us n over 2. Then we multiply it with the sum of the first and last term. In sequence, the first term is denoted by a sub 1 and the last term can be denoted by a sub n. So therefore, we're just going to multiply this with a sub 1 plus a sub n. And this will be our formula for the arithmetic series. Okay, so now how to use the formula? The S sub n equals n over 2 times a sub 1 plus a sub n is our formula for the arithmetic series. So therefore, we can now use this to add numbers like this. 3 plus 6 plus 9 plus 12 and so on up to 36, which is a sum of terms of arithmetic sequence with terms 3, 6, 9 and so on up to 36. So how do we use the formula? First, we have to identify the variables in our formula. So we have the a sub 1, which is we all know that it is the first term. On our problem, the first term is 3. Then we also have a sub n, which is for this one, our last term. And on our problem, the last term is 36. Then, another variable that we should have is n, which is the position of a sub n, which in our example is 12 because 36 is the 12th term. So after finding the values of those variables, we can now use the formula s sub n equals n over 2 times a sub 1 plus a sub n. So all we have to do is to replace the variables with the values that we obtained. So therefore, we're going to replace n with 12, we're going to replace a sub 1 with 3, and we're going to replace a sub n with 36. Thus, our equation will become s sub 12 is equal to 12 over 2 times 3 plus 36. Then we solve for this one, we will have s sub 12 is equal to 6 times 39. 6 is from 12 over 2 and 39 is from 3 plus 36. So solving for this, we will have s sub 12 is equal to 234. So therefore, the sum of 3 plus 6 plus 9 plus 12 up to 36 is 234. So, we're done. So thank you for watching and hope you have learned something from this video.